I believe this is from chapter 6 for Math 1324. We're going to be going over, I believe, section 6.1, 6.2, and 6.3. Okay, the first thing we're going to go over is instance of two linear equations in two variables. Determine whether an order pair is a solution to the system of equations. Then we're going to solve the systems by graphing, substitution, elimination method. Then we're going to see how we use it in real life. After that, we're going to be doing larger systems of equations, and then solving by the elimination method, matrix method, and also how we apply it in real life. Okay? So the first thing I'm going to go over are solutions of a system of linear equations. Number 1 and number 2. It says determine whether the given ordered list of numbers is a solution to the systems of equations. So here we have number 1. So they're saying if the point -1, 3 is a solution to these two equations. Okay, I'm going to call so all we do is plug in -1 for x and 3 for y on both equations. So let's call the first equation equation 1, which is 2x plus y equals 1. And equation 2 will be -3x plus 2y equals 9. So let's take equation 1, and we're going to plug in the point -1, 3 for x and for y. So you notice x is -1 and y is 3. So after we evaluate it, we get -2 plus 3 equals 1. So -2 plus 3 equals 1, so 1 equals 1. So it's true for equation number 1. But for the point to be a solution to the system, it has to be true for both equations. So once it's true for the first equation, then we go to the second one. So again, I'm going to plug in -1 for x and 3 for y. So here we're going to get 3 plus 6. 3 plus 6 is 9, so 9 equals 9. So in other words, since the order pair -1, 3 makes both equations true, then the order pair is a solution. So this point is a solution to these two equations. Now I'm going to repeat the process for number 2. But for number 2, it's a different point and they're different equations. So we're going to plug in 2 for x and -0.5 for y. So again, this will be equation 1 and 2. So first, we start with equation 1. We're going to plug in 2 for x and -0.5 for y. So here we get 1 minus 4. So 1 minus 4 is -3, right? So this is true. If this was false right here for number 1, say there was another number besides -3, then we stop there. Okay, but since it's true, we continue to equation number 2, and we plug in 2 for x and -0.5 for y. So here we get 2 minus 2.5. -0.5 equals to -5, so this is not true. So that's not a solution. Since the order pair 2 and -0.5 does not make both equations true, then the order pair is not a solution. So number 1 is a solution, and number 2 is not. Now, this is a system of two linear equations and two variables. So this is called like the graphing method. Okay, now, it can be either three ways that, for a system, for the solution to a system. Either if they cross, it's going to be one solution. They cross at exactly one point. Figure B has a line on top of a line, which means it's going to be infinite solutions. Or if they don't intersect at all, if they're parallel, it's going to be no solution. Okay? So for example, here on A, one solution means when you're solving the system, right? If you get something like x equals to A or y equals to B, and you let A, B be real numbers, then that means it's going to be one solution. I'll show you an example when we're solving by the elimination method or by substitution, okay? And this is called, like, for example, if you get something like x equals 3 or y equals -2, it means you can have one solution. Infinite solutions means that there's not going to be no x or y. You see example 3 equals 3 or 0 equals 0, right? These are both true, so that means it's going to be infinite solutions. And there's no y, nor no x, nor y. And I'll also show you an example when we solve it by substitution or by the addition method. If you get something like a equals to b, let a and b be real numbers, right? Something like, example, if you get something like 3 equals 4, or there'll be no solutions because 3 does not equal 4. And also there's no x or y. Right now, perhaps it doesn't make sense what I'm talking about here, but once we get to solving by substitution or the elimination method, then it's going to make sense. Okay? If you have a solution, it's called consistent independent system. If you have infinite solutions, it's going to be consistent dependent system. If you have no solution, it's going to call inconsistent system. Okay, now, number 3, solve the system by graphing. So by graphing, again, this is equation 1 and equation 2. So we're going to graph it by using the y equals to mx plus b. Here, my m, my slope is 3, right? So we put it 3 over 1. And my b is my y-intercept, which is 0, negative 6. And this, the b, or the y-intercept, this is my starting point. Okay, so I'm going to start 0, negative 6. There's my point 0, negative 6. Then my slope, it means that I'm going to go up 3, 1, 2, 3, and 1 across. And then we connect the 2 points. So that's my line. Okay? Now for equation number 2, if we're graphing by using put it in slope-intercept form, we have to put it in y equals to mx plus b. So for that, right, we have to set up the equation in y equals to mx plus b, which is called slope-intercept form. So I need to solve for y, or isolate y. So here I'm going to add 5x to both sides. So if I add 5x on the left side, it's going to be 0. If I add 5x on the right side, we're going to have 5x minus 10. Then my next step, I have to divide negative 2 to both sides, right? Or every term. So negative 2 divided by negative 2 will give me y. So y equals to a negative 5 over 2x plus 5. So again, my slope, my m, is equal to negative 5 over 2, which means it's going to go down 5 and 2 to the right. And the b is my y-intercept. So this is my starting point. 0, negative 0, 5 is my starting point, which will be about right there. See, there's my point. Then I'm going to go down 5, right? Because this is a rise with a run, so I'm going to go down 5 and 2 across. 1, 2, 3, 4, 5, and 2 across. So the next point should be right there. So we connect the points. So the point 2, 0 is for both lines intersect. So that's my solution. The point where both lines intersect is the solution, which is 2, 0. Okay, now I'm going to solve the very same system by using another method, which will be substitution. Okay. Again, this is consistent, right, because we have one solution. So then, again, this is number 4. It's the very same system, but we're going to use another method. By substitution, let's call the first equation equation 1, the second equation 2. Solution, since y is oscillated on equation 1, we have to substitute 3x minus 6 for y on equation 2. So since we already know the value of y, right? The value of y is 3x minus 6. So I'm going to plug that in right there for the y is. Okay, so we're going to go to number 2. I'm going to substitute 3x minus 6 for y. You see, there's my y, so I'm going to plug here 3x minus 6. Then I'm going to distribute, right? So there'll be negative 5x minus 6x plus 12 equals 10, negative 10. So now I combine like terms. Negative 5x minus 6x will give us negative 11x plus 12 equals negative 10. So now I have to subtract 12 from both sides. So it's going to be negative 10 minus 12 will give us negative 22. Now I need to divide both sides by negative 11. That should give us x equals 2. Okay? So x equals 2. So then we have to go back we need to find the value of y. So we need to go back to either equation 1 or 2. Since you're plugging 2 for x in either equation 1 or 2, whatever is easier for you. In my opinion, since y is already isolated, I'm going to plug in the value on equation number 1. So I'm going to plug in 2 for x. All right? So 3 times 2 is 6. 6 minus 6 will be 0. So what's my solution? X equals 2 and y equals 0. So there's my solution. Okay? So again, it's consistent independent system. Now I'm going to do the very same thing, guys, but the next thing that I'm going to do when I have the value for x, I'm going to go to number 2. To equation 2, just so you know that you can use either equation to solve for y or for x. Okay, so I'm going to do the same thing as before. I don't know, this is something different, guys. I'm sorry about that. I thought that I had done it again. But here, guys, we're going to use the elimination method. But what I mean right now, guys, instead of going plugging in 2 here on equation number 1, I could have gone and plugged in 2 on equation number 2 for x. But that would have taken more work. Okay? So now this is another method, is by using the elimination method. So solution: to use elimination method, both equations must be in the form of ax plus by equals c. We need to rewrite equation 1 in the proper form. Okay, so I need to have it in ax plus by equals c. So here, right, I'm going to subtract 3 to both sides. So we get negative 3x plus y equals negative 6. So this is my new equation 1, right? It's the same equation, but I'm trying to rewrite it in the form ax plus by equals c. So this is equation 1, and that's equation 2. Now here, it's either you can eliminate the x's or the y's. It's up to each student individually. But again, in my opinion, since the y here is isolated, I can multiply equation 1 by 2. Why 2? Because 2 times y will give me 2y. Then when added to the second equation, 2y minus 2y will give me a 0. Okay, so but I need to multiply 2 times every term or both sides of the equal sign. So 2 times negative 3x is negative 6, negative 6x. 2 times y is 2y, and 2 times negative 6 is negative 12. And equation 2 stays how it is, right? So if we add them, right, negative 6 minus 5 will give me negative 11x, and the 2y minus 2y will give me a 0. So after we simplify these two equations, right, after we add them, we're going to get negative 11x equals negative 22. My next step is we divide both sides by negative 11. So we get x equals 2. So this is my value for x. Now, need to find the value for y. We can plug in 2 for x in either equations 1 or 2. What is easier for you? And again, in my opinion, it's easier to go to number 1 because the y is already isolated. So I'm going to plug in 2 for the x. So I get y equals 0. So this will be the point 2, 0. So now I already showed you 3 different ways: by graphing, by substitution, and by the elimination method, and we solve the same system. Okay. Consistent independent system. Okay, now I believe here, guys, I'm gonna instead of eliminating the y's, I'm gonna eliminate the x's. Okay, so again, this is the same thing from the previous slide up to this point here. All right? So need to eliminate the x's or y. So whatever is it for you. So here, guys, I'm going to eliminate the x's. Just so you know that we get the same thing. But eliminating the x's will do a little more, we're going to do a little bit more work. So for example, to eliminate the x's on both equations, equation 1, I need to multiply by the coefficient in equation 2. So we're going to multiply equation 1 by negative 5 and equation 2 by 3. Okay, because since they're both negative at the beginning, one has to be negative, one has to be positive. So if I multiply negative 5 times negative 3 will give me a 15, and 3 times 5 will give me a negative 15. That way, when we add them, they're going to cancel, or they're going to be 0. So again, negative 5 times negative 3 is 15x. Negative 5 times positive y will give me negative 5y. Negative 5 times negative 6 will give me a 30. 3 times negative 5x will give me negative 15x. 3 times negative 2y will give me a negative 6. And 3 times negative 10 will give me a negative 30. After we add these right, it's going to give us negative 11y equals to 0. We divide both sides by negative 11y. So we know that y equals 0. Now we need to go back to either equation 1 or 2. So here I decided to go to equation 2. For equation 2, I'm going to plug in 0 for y. So if I plug in 0 for y, right, we're going to get negative 5x equals to negative 10. Then we divide both sides by negative 5, which will give us x equals 2. See, so that's my solution. And again, it's consistent, independent system. So again, students, so once you become familiar, or once you begin to get more practice on solving systems of equations by the elimination method, then you can begin to see what's easier for you. Okay, it's up how you want to solve the system. Okay, now, again, this is solving by the system by the elimination method. Hey guys, but before I forget, let me go back to the previous slide. Okay, hey guys, remember when I told you at the beginning when I had this graph and I said when x equals to a number, or to a, say to a and y equals to b, something like that? That was one solution, right? So for example, here, when we're solving, right, we get something like y equals to a number, right, or to a. Right, so that means one solution. So right away, we know here is going to be one solution because we got a value for either x or y. Okay. Now here, this will be like example, like the graph. I believe it was figure 6b. Okay, here we're going to try to eliminate, right, the x's. So I'm going to multiply this one by negative 2. So negative 2 times 3x will give me negative 6x. Negative 2 times negative 2y will give me 4y. Negative 2 times 4 will give me negative 8. Then if we add it to the second equation, it's going to give us 0 equals 0. Remember this one, guys? It was infinite solutions. Why? Because there's no x's or y's, and 0 does equal 0. So that means it's going to be infinite solutions. That was consistent, dependent system. It's dependent because we can choose any value for x or y, and we're going to get a value for, say we can choose any value for x, we're going to get a value for y. That means the y depends on the x, or vice versa. Okay, now number 7. Again, we're going to solve it by the elimination method. So again, we're going to try to cancel the x's, so I'm going to multiply equation 1 by negative 3. In this case, negative 3 times 2x will give me negative 6x. Negative 3 times 5y will give me negative 15y. Negative 3 times 8 will give me negative 24. Equation number 2 stays how it is. But here, we're going to get 0 equals to negative 6, and that's not true. And going back, I believe, to the second slide, where we had those 3 graphs, and we have this means there's no solution because this is not correct. This is not true. 0 does not equal negative 6. So that means these lines will never intersect. That means the lines are parallel, which is no solution. And I believe this is called inconsistent system. Okay. Okay, now, I gave you an example of each one. I gave you already an example of solve it by graphing, solve it by substitution, solve it by the elimination method, and then I already explained one solution, infinite solutions, and no solution. Now I'm gonna show you an example how does this apply like a real life applications problem. Okay. So for number 8, it says a 200-seat theater charges $8 for adults and $5 for children. If all seats were filled and the total ticket income was $1,435, then how many adults and how many children were in the audience? So how do we solve this type of a problem? Well, first of all, we need to find two equations. This is how I like to explain to my students. We're going to use seats with seats and money with money. What does seats with seats mean, right? So it means that the adult seats plus the children seats must equal 200 seats, right? So it's going to be x. So we're going to let x equals to adults, and y equals to children's C's. Right there are 200. So it's going to be x plus y equals 200. That's equation number one. Equation number two, we're gonna keep the same variables for adults and the same variables for children, but now we're gonna do money with money. So adults, right, are $8. So this is gonna be 8x. Children's tickets are $5. So since y represents children's C's, that's gonna be 5y. And what was the total revenue or total income? Was 1,435. So this is going to be 8x plus 5y equals to 1,435. That's equation number two. Now we have our system, equation one and equation two. Okay. So now you can solve it by, this will be kind of hard to solve it by graphing because you have to have real good graphing paper, and graphing is not recommended. You can solve it by substitution. But I truly believe the easiest way is to solve it by using the elimination method because it's already set up in that form on the ax plus by equals c. So here you can eliminate the x's or the y's, whatever you think is best. In my opinion, or what I would do, I would eliminate the x's. So I need to multiply this whole equation 1 by -8. Why -8? Because -8 times x will give me -8x. Then when you add it to the second equation, -8x plus 8x will give me a 0x. That's why we multiply it by -8. So once I multiply every term by -8, I get -8x minus 8y equals to -1,600. And equation number 2 stays how it is. Now we add them. That's going to give me 0. This is going to give me -3. And -1,600 plus 1,435 will give me -165. Then we divide both sides by -3. So y equals to 55 because -165 divided by -3, the result will be 55. Now I need to go back to either equation 1 or 2. What's easier? Again, my opinion, equation 1 is easier because the coefficient for x and y are 1. So they'll be easier to do the math. So we know that y equals 55, so I'm going to plug in 55 for y. Then we subtract 55 to both sides. So 200 minus 55 will give us 145, which means x is 145 and y equals to 55. And x represents, what was it? Adult tickets. So there's going to be 145 adults in the audience and 55 children also in the audience. So these are my solutions. Okay, now let's go to, I believe this is section 6.2. Larger systems of linear equations. So these are, now we're going to have, before it was only x and y, now we have x, y, and z. So how can we solve a system in this manner? Okay, that's equation 1, equation 2, equation 3. It's always wise at the beginning to try to put equation 1 with the coefficient for x to be 1. So here we can actually switch. We can rearrange a possible coefficient of 1 on the x being equation 1. So here we can switch equation 1 and 2. Right? So equation 2 became equation 1 and equation 1 became equation 2. Because it's easier to do the math. Okay? Okay, now. But here, guys, we have to have some kind of plan. Okay, so what's my plan to solve it? If you follow this plan, guys, here, you can never go wrong. Okay, you cannot go wrong. Okay, so what's the plan then? I'm going to get equation 1 and equation 2 and eliminate the x's for both. I'm going to use equation 1 and 2 and 1 and 3, eliminate the x's. So after that takes place, I'm going to get here the new equation 2 and new equation 3. Okay, then my next step, I'm going to take equation 2 and equation 3, the new ones, and eliminate the y's. Then after that, you're going to get something like z equals to c, and c will be a real number. Okay. Then after all the steps, your system should look like this, or something similar to this. Then I'm going to back substitute. Okay, so let's begin then. So we're going to get equation 1 and equation 2, right? Equation 1 and 2. So we have to eliminate the excess. So equation 1 must be multiplied by negative 2. Again, why negative 2? Because negative 2 times x will give me negative 2x. Then when I add it to equation 2, negative 2x plus 2x will give me a 0x. And that's how I can eliminate the x on equation 1 and 2. Okay, so negative 2 times x will give me negative 2x. Negative 2 times negative 3y will give me positive 6y. Negative 2 times positive 2z will give me negative 4z. And negative 2 times 0 will give me 0. Right? And equations 2 stays how it is. So here we're going to get that 0x. Here we're going to get 4y minus 3z equals 3. So this is my new equation 2. Okay? Now I repeat the process for equations 1 and 3. So then equation 1, I need to multiply by negative 3. Okay, after I multiply negative 3 times every term, we're going to get negative 3x plus 9y minus 6z equals to 0. Equation 3 stays how it is. Then after we add them, we're going to get 10y minus 7z equals to 7, and that's my new equation 3. So what's my next step? I'm going to get the new equation 2 and the new equation 3 and get rid of the y's. Okay. So here, guys, I know that my least common multiple between 4 and 10 is 20. But at times, students struggle by getting the LCM, the least common multiple. So instead, I'll just multiply equation 1 by negative 10 and equation 2 by 4. Right? This way, you don't have to worry about the LCM. But if you can do it, if you can simplify it here, it will be less work at the end. But I'm doing it pretending that the students do not know nothing. This way, at whatever level they're at, they'll be able to pick up. Okay? So after I multiply negative 10 times every term on equation 2, we're going to get negative 40y plus 30z equals to negative 30. And after I multiply 4 times every term on the new equation 3, we're going to get 40y minus 28z equals to 28. So that'll be 0. This will be 2z equals to negative 2, right? We divide both sides by 2. So z equals negative 1. Right? Now there's my system. Right? If I wanted to, I could have placed for equation 2, I could have placed this one here. The 10y minus 7z equals 7. And then for equation 1, I could have put either one of these, but it's easier to keep it in this format. Now I'm going to go and back substitute. So I'm going to go to equation 2. I'm going to plug in negative 1 for z. Right? Negative 1 for z. So this will give us 4y plus 3 equals 3. We subtract 3 from both sides. We get 4y equals 0. So that means that y, we divide both sides by 4, so y equals to 0. Now I'm going to go back to equation 1. I already have the values for z and the values for y, so plug them in there and solve for x. Right, so y is 0, and z is negative 1 from here, right? So this will give me x minus 2 equals 0, so then we add 2 to both sides, so x equals 2. So my solution will be 2, 0, negative 1. That's my solution. Okay, that was number 9. Now I'm going to explain the Gauss-Jordan method, elimination method. This method, the Gauss-Jordan method, is solving systems, linear systems of equations with 3 variables, by using matrices. Okay, so objective. So this is linear systems of equations. Then we're going to go to augmented. Then we're going to go to RREF, which means reduced row echelon form. So this is a system of equations that we just solved, right? So how do you put it in augmented matrix? For example, we only put the coefficients because we know on column number 1 will be the x's, on column number 2 will be the y's, column number 3 will be the z's, and column number 4, over here on this side, will be the what is equal to, which are the constants. You see, so we have 1, negative 3, 2, 0, and they came from the coefficients on the first equation. Then we got 2, negative 2, 1, 3, Again, it came from the coefficients of the second equation. And then we got 3, 1, negative 1, 7, and they also came from the coefficients of the third equation. So after we solve it, this is how the answer should look like. Right, which means these are my x column, this is the y column, the second column, my third column will be the z column. So this is the same thing as x, 1x plus 0y plus 0z equals 2. In other words, x equals 2. Y equals 0, and z equals negative 1. But how? How are we going to do it? Okay, now, I modified the Gauss-Jordan elimination method back in 2006 when I was a student. I was actually doing something for honors program, and part of my honors program was to help some of my fellow classmates. And the instructor also asked me to write like a 5-page report on what different techniques that I use. So I modified the system, and I thought that I had invented something or came up with something, because back then it had a lot of fractions. So anyway, I modified the system back in 2006, and now it's it's perfected because it only takes 3 steps. The 3 steps, right? Here I'm going to use the letters from the alphabet, and we're going to let all letters be real numbers, right? All these are real numbers. So for augmented matrix, right? This is going to be augmented matrix. Then this will be the reduced row echelon form, the REF, right? Which means x, the value here, right? That'll be my x value. This will be my y value, and this will be my z value. Okay, now I do it in 3 steps. This is row 1, row 2, row 3. So my first step, right, is going to be also, this is all color coded. My first step in blue, right, this is the blue will be my first step, the green will be my second step, and the red will be my third step. So for the first step, I always have every step has at least, at the most two A and B, right? Because that has to be a 0, and that has to be a 0, right? Because the column 1 on row 2 and row 3, they must be zeros. So this has to change, and that has to change. So after I execute step 1, this is how it should look like, something like that. Okay, like these 2 zeros. Now for step 2, the B must be a 0, and the Q must be a 0, right? Because this must be 0. That's why the color coded in green means I'm going to execute the second step, which are the zeros in green, right? So that's going to be a 0, and that's going to be a 0. So after I execute step 2, right, I have zeros for here for the second and third column on the x values. I'm going to have zeros for the first and third column for the y values. Now, step 3, the u and the n must be zeros, right? Because the place for the u is going to be 0, and the place for the n is going to be also 0. That's the plan for step 3. After I execute step 3, right, and then this means we're going to simplify it possible if you do each step. This way, it's going to guarantee that you get at the most three steps. That's my solution. Now, at times, students get confused with other letters. They say, Mr. Isasi, well, why so many letters? And at times, students, they don't understand the concept. They don't know that letters mean real numbers. They get confused by this notation. So then what I do, I just put number signs. So that way, they won't be confused. And again, it's going to be the same thing as before, but instead of letters, it will just be numbers, right? And this is my plan. So my step 1, right, these must be zeros, again, as before. That has to be a 0, that has to be a 0. So after I execute step 1, these 2 will be zeros, right? That way students will not be confused because these are all numbers instead of letters. That way that way nobody will be left out. And again, step 2, that's going to change, right? That's going to be a 0 and a 0, which means there has to be a 0. That's why the arrow goes here on row 1. And y value on row 3 must be a 0. That's why the arrow goes here on row 3. After I execute step 2, it should look something like this. Now we're up to step 3, right? Step 3, there has to be a 0, right? And there has to be a 0, right, from here. So that means that's going to change, and that's going to change. So after I execute step 3, again, we simplify if possible as you do each step, and you're gonna notice what I mean by this statement here, right? Then that's my answer. X equals to whatever number is there, Y equals to whatever the number is there on the second row, fourth column, and Z will be whatever the number is here on row 3, column 4. Okay, now let's put the 3-step plan in action. And again, I believe this is the same system that we had at the beginning, right? When we solved the system of 3 equations. Okay, I want to put it in reduced echelon form. That's my plan, right? And this was the answer, 2, 0, negative 1. So on this slide, I'm going to do step 1. On the next slide, I'm going to do step 2, and then on the step that follows step 3, I'm going to do the next slide after the next one. This is row 1, right? This is row 2. Row 3 will be 3, 1, negative 1, 7. So now the 2, right? So if we're going to use, we're going to use row 1, right? Step 1, row 1 stays the same. See? So that must be a 0. That's why I'm going to put it in blue. And the 3 must also be a 0. Okay, now I'm going to use row 1, okay? So to get rid of to have a 0 here, where the 2 is, on row 2, I'm going to multiply row 1 by negative 2. And again, why negative 2? Because negative 2 times 1 will give me negative 2. Then when I add it to the 2 here on the second row, it's going to give me a 0. Okay? So it's going to be negative 2 row 1 plus row 2. In a similar fashion, I'm going to multiply negative 3 times row 1 and add it to row 3. Because negative 3 times 1 is negative 3. Negative 3 plus 3 will give me a 0. Okay, now here on the bottom is my work. Okay, so I'm going to do negative 2 row 1. It's going to be negative 2, right? Negative 2 times row 1. This is my row 1 here. Right, which equals to negative 2, 6, negative 4, 0. Now plus row 2. Row 2 is 2, negative 2, 1, 3. So 2, negative 2, 1, 3. After we add them, we get 0, 4, negative 3, negative 3. So this is my new row 2. Okay. Now I'm going to do the second part of step 1. Negative 3 row 1, right? Negative 3 times row 1 will give me negative 3 times everything in row 1. 1, negative 3, 2, 0. That's what's here. So it'll give me negative 3. Negative 3 times negative 3 will give me 9. Negative 3 times 2 will give me negative 6. And negative 3 times 0 will give me a 0. Plus row 3. So row 3 stays how it is. 3, 1, negative 1, 7. After we add them, we're going to get 10, negative 7, 7. So that's my new row 3. On the next slide, I'm going to have all this right here, right? Just this part here. Then I'm going to execute step 2. Okay? So remember, step 2, these 2 must be zeros, right? Which pertains to the negative 3 and the 10. So then, step 2, right? We're going to use step 2. We're going to use row 2. So row 2 stays how it is. So this must be a 0, and the 10 must also be a 0. So I'm going to use row 2. So here I'm going to multiply row 2 by 3 and row 1 by 4. So it's going to be 3 row 2 plus 4 row 1. And to eliminate the 10 on the third row, I'm going to multiply this row 2 by negative 10 and row 3 by 4. So negative 10 row 2 plus 4 row 3. And here on the bottom is my work. 3 row 2 is going to be 3 times row 2, which is 0, 4, negative 3, 3. That's what's here. So that should give us 0, 12, negative 9, 9. Plus 4 row 1, right? So 4 times row 1, I'm going to multiply 4 times 1, 4 times negative 3, 4 times 2, and 4 times 0, which will give us 4, negative 12, 8, and 9. After I add them, right, it's going to give me 4, 0, negative 1, 9, and that's my new row 1. In a similar fashion, I'm going to do the next step for step 2. I mean the step B for step 2. Negative 10 row 2 plus 4 row 3. So negative 10 times row 2 will give us 0, negative 40, 30, and negative 30. Plus 4 row 3, right? This is my row 3, which is 0, 10, negative 7, 7. So 4 times 0, 4 times 10, and 4 times negative 7, and 4 times 7 will give us 0, 40, negative 28, and 28. After we add them, we get 0, 0, 2, negative 2. Here's what it means to simplify, right? Every term can be divided by 2, right? So simplify. So this will give us 0, 0, 1, negative 1, and that's my new row 3. Now, on my next slide, I'm going to have all this right here, steps 1 and 2 up to here. Then we're going to execute step 3. Okay? So now for step 3, remember these must be zeros, which pertains to the negative 1 on row 1 and negative 3 on row 2. So these must be zeros. So since we're using step 3, we're going to use row 3. Row 3 is the same. That's going to be a 0, and the negative 3 must be a 0. So if we're going to use row 3. So here we're going to use row 3 plus row 1. We're going to use 3 times row 3 plus row 2. And here's my work, row 3 plus row 1. Right, so this is my row 3, 0, 0, 1, negative 1, and my row 1 is 4, 0, negative 1, 9, right? And I got it from here. So after we execute that, it's going to give us 4, 0, 0, 8. And now every term can be divided by 4, so here we're going to simplify. So it's going to give us 1, 0, 0, 2. So that's my new row 1. Now again, in a similar fashion, we're going to do the step B on, the second part for step 3. Which would be 3 row 3, right? So 3 times 0, 0, 1, negative 1 will give us 0, 0, 3, negative 3, plus row 2. Plus row 2, right? It's going to give us row 2 is 0, 4, negative 3, 3. After we add them, it's going to give us 0, 4, 0, 0, right? But we want a 1 here instead of a 4, so we're going to divide everything by 4. Simplify. So that's my row 2. So what's my solution? Choose 0, negative 1. Okay, now let's do one together. Okay, so this one here, right? I left all the boxes. This will be the work for step 1. These two here. This will be the work for step 2. These 2 boxes here. This will be the work for step 3. These 2 boxes here. Okay. So again. From the beginning, right? So this is step 1. We're gonna step 1, row 1 stays the same, and the two and the negative 1 must be zeros. So then I'm gonna use row 1, right? So it's gonna be negative 2, row 1 plus row 2. It's gonna be row 1 plus row 3. And here's my work. Negative 2 row 1 plus negative 2 row 1 plus row 2. My negative 2 row 1 will be negative 2 times 1 times 2 times negative 1 and times 6, right? I got it from here. So that will give us negative 2, negative 4, 2, and negative 12. Plus row 2, right? So it's going to give us 0, negative 5, 5, and negative 5. And again, we can simplify, correct? We can divide everything by negative 5. So everything by negative 5 will give us 0, 1, negative 1, and 2. That's my new row 2. Now, for the second part of step 1, row 1 plus row 3. There's my row 1. There's my row 3. So we're going to add them. 0, 1, 0, 1. That's my new row 3. Now, we're down to step 2. So step 2, these two, the 2 and the 1 must be zeros right here. The 2 and the 1 must be zeros. So step 2, we're going to use row 2. So row 2 stays the same. The row 1 must change, right? The 2 must be a 0, and row 3 must change. The 1 must be a 0. So we're going to do negative 2, row 2 plus row 1. And here's going to be -1, row 2 plus row 3. And here's my work. So -2 row 2, right? From here, -2 row 2 will give me -2 times row 2, which is 0, 1, -1, 2. That should give us 0, -2, 2, and -4. Plus row 1. Row 1 is 1, 2, -1, 6, right? And I got it from row 1 over here. After we execute it, or after we add them, it's going to give us 1, 0, 1, 2. That's my new row 1. Now let's do the second part for step 2. -2 row 2 is going to give us 0, -1, 1, and -2. Plus row 3. So row 3 was 0, 1, 0, 1. There it is, 0, 1, 0, 1. So after we add them, it's going to give us 0, 0, 1, -1. That's my new row 3. Now for step 4, step 3, we're going to use row 3, and the -1 must be a 0 here, and the 1 must be a 0 also for row 1. So that's going to change, and row 2 is going to change. So it's going to be -1, row 3 plus row 2. And it's going to be row 3, -3 row 3 plus row 1, and row 3 plus row 2. And here's my work. -1 row 3 will give us 0, 0, -1, 1, plus row 1. Right, row 1 was 1, 0, 1, 2. After we add them, it's going to give us 1, 0, 0, 3. That's my new row 1. Row 3 plus row 2, there's my row 3, which was 0, 0, 1, -1, plus row 2, which would be 0, 1, -1, 2. After we add them, it's going to give us 0, 1, 0, 1. That's my new row 2. So what's my solution? My solution will be 3, 1, -1. X equals to 3, y equals to 1, and x equals to -1. That's my solution. Okay, now I believe this will be the last problem here. We got like 6 minutes. How do you apply that in real life? So this is very similar to the other applications problem that I did for the linear of the linear of two equations with 2 variables. Here we can have the linear of 3 equations with 3 variables. So to start off, my solution, we need to find 3 equations. People with people, right? So the first is going to be people with people and money with money as before. It says here, tickets to a band concert cost $5 for adults, $3 for teenagers, and $2 for preteens. There were 570 people at the concert. The total ticket receipt were $1,950. Okay, the last sentence, we'll save it for equation 3. It says, 3/4 as many teenagers as preteens attended. How many adults, teenagers, and preteens attended the concert? So people with people, right? So we're going to let x equals to adults, y equals to teenagers, and z equals to preteens. And there's a total of 570, right? So it's going to be x plus y plus z equals to 570. Now for equation number 2, right? Money with money. So since adults, right? Adult tickets was x, so it's going to be 5x. Teenager tickets were $3, so it's going to be 3y. Since for preteens, right, there were $2, so that's going to be 2z. And what was the revenue? How much money? The total receipt was $1,150. So it's going to be 5x plus 3y plus 2z equals to 1950. Right? So we found equation 1 and equation 2. What's missing? Equation 3. So with equation 3, right, we're gonna use the last sentence here. 3/4 as many teenagers, as many teenagers as preteens attended. So at times this is kind of confusing to set up. Okay, so since y was teenagers, right? Y was teenagers and z was preteens. So this is what it should be. Y equals to 3/4 z. But this doesn't sound right, right? But that's correct. So what I tell my students is to write it how it sounds. If it's difficult, write it how it sounds, then flip it. By flip it, maybe I use the wrong word for flip it, but what I mean by flip it, okay? I'm gonna show you what I mean by flip it. Doesn't it sound 3/4 as many teenagers, right? 3/4 y equals to z. That's what it sounds like, correct? But then flip it. Put the 3/4 where the z is. Right? That's what I mean by flip it. And again, maybe I used the wrong wording because they don't explain it like this in the book. They just say that that this equation is equation number 3. That's all they tell you. So I use this this wording, but maybe, like I said, maybe the wording is bad. Maybe I should just put the coefficient for y for z instead, okay, or something like that. Now we want to put it in the form ax plus by plus cz equals d, right? So here I want to let it equal to 0 or to a constant. So I'm going to multiply everything by 4. So 4y equals 3z. Now I'm going to subtract 3z. So I have 4y minus 3z equals 0, and that's my third equation. So this is my system. Now, for lack of time, right, we don't have time to actually work it, but if I ever teach lecture, right, again for this course here, I can maybe use this PowerPoint, and maybe I'll let you guys, let the students actually work it out and see how we can get the answer. You can do it by matrix, by the Gauss-Jordan method, or you can do it by remember the plan that I had, that you have 3 equations, and you use 1 and 2 and 1 and 3 to get rid of the x's and so forth. You can use that example also. But this is what the answer should look like right after you try it. X should be 220, y should be 150, and z should be 200. Okay, that's the actual answer. Also, you can actually use matrix and put it into a calculator. I like to show the students that method, right, to plug it in, but not after the exam, because they may use that in the exam. But I tell my students that they have to show me the work. But put in the calculator, they can actually check their work if it's right. Okay, but again, you can plug that into the calculator, into a TI-83 or TI-84, and get the answer. So there were 220 adults, 150 teenagers, and 200 preteens. Okay, now guys, so that's it for this PowerPoint. And I believe, attention, if you did not attend the workshop, you may receive credit by filling out the survey and answering the questions below. Right, so you can ask Ms. Shuka for contact Ms. Shuka how to receive credit, or else you can also ask Ms. Patricia. Okay. Okay, guys, I'm gonna stop sharing my screen because I'm done with this workshop. And please let me know if you have any questions.
Thank you, Mr. Zassi. That was wonderful.
You're welcome. You're welcome.
All right, well, to wrap us up, guys, we have one more week of TVEs. On Monday, we have mindfulness tips to help students relax and focus before their exams. And then on Tuesday, we have a special Happy Math Hour, because it's on Tuesday. We're going to have Math 1314. This isn't quite right. Math 1314 is doing a final exam review. And then Math 1324 is doing sets, concepts of probability, permutations, and combinations. So we hope to see you again next week. You've been a wonderful audience, and have a wonderful day. Thank you, Mr. Zassi.